velocity. And lastly, what is wave equation? Wave equation, we say this is the equation of wave velocity. So wave velocity, wave speed or wave velocity, this is distance traveled by wave in 1 second. ऐसा यूनिट स्पीड के मीटर अपॉन सेकेंड होते हैं. स्पीड हमें पता है डिस्टेंस अपॉन टाइम है, डिस्टेंस अपॉन टाइम. इफ डिस्टेंस इज लैम्डा, लैम्डा इज वेवलेंथ, देन द टाइम टेकन इज टाइम पीरियड t. So v is given as lambda by t. We can use this formula, or we can replace 1 by t by frequency. Then the formula becomes v is equal to f lambda. F can be written as n stand for frequency, f stand for frequency. So velocity is f lambda or velocity is n lambda. So we can use either of these two equations to solve numerical problems. Velocity is lambda by t or velocity is f into lambda. This equation we call this as wave equation, or this is the way to find the wave speed. Now few important definitions. Wavelength of a wave is the length of one wave. It is the distance traveled by the wave during the time any one particle of the medium complete one vibration about its mean position. So जितने टाइम में एक पार्टिकल एक वाइब्रेशन पूरी करेगा, उतने टाइम में वेव जो डिस्टेंस ट्रैवल करेगी, मूव करेगी, वी डिफाइन इट एज वेव लेंथ. We may also define wavelength as the distance between any two nearest particle of the medium vibrating in same phase. So दो nearest particle wave में जो same phase में हैं उनके बीच का distance is also wavelength. In transverse wave motion, transverse wave में lambda is distance between two consecutive troughs or two consecutive crusts. In longitudinal wave motion, the lambda distance जो है wavelength, this is the distance between two consecutive rarefaction or two consecutive compressions. Frequency of vibration of a particle is defined as the number of vibration completed by a particle in 1 second. So number of vibration completed by a particle in 1 second, or one vibration is equal to one wavelength. So we can also define frequency as the number of complete wavelengths completed by wave in 1 second. So we can define frequency in either of the way, either in terms of vibrations or in terms of wavelengths. So this is number of vibrations completed by particle in 1 second, or this is number of complete wavelengths completed by wave in 1 second. Time period, it is the time taken by particle to complete vibration, one vibration, about its mean position, or it is, we know that vibration is equivalent to one wavelength. So time period of a wavelength is the time taken by the wave to travel a distance equal to one wavelength. So either you can say it is time taken to complete one vibration, or you can say it is the time taken by wave to travel a distance equal to one wavelength. Amplitude, this is the maximum displacement of the particle from its mean position. Phase, the phase of a vibrating particle at any instant is its state or condition regarding its position and direction of motion at that instant. तो phase क्या होती है? Phase of a particle, it tell you about its position and direction of motion while it is vibrating. So the phase of a vibrating particle at any instant is its state or condition regarding its position and direction of motion at that instant. It is measured as the ratio of the displacement of the particle at any instant to the amplitude of the particle. So there are different ways of finding phase or representing phase. So one is either it is ratio of displacement to the amplitude, or it is the fraction of the time interval that has elapsed since the particle crossed the mean position. Okay. Second way, first is it is ratio of displacement or amplitude. Second is it is the fraction of time interval that has elapsed since the particle crossed the mean position, and also it is equal to the angle swept by the radius vector since the vibrating particle last crossed its mean position of rest. So there are different ways of representing phase of a particle. For example, this particle P, we say this complete circle, say it represent we divide this complete circle into capital T time, 8 equal intervals of time period. So this here the time period, this is T/8. So in terms of time period, the phase can be, we can say that phase is T/8. When we talk about angle, so this angle, because this complete circle while following this path, the angle described is 2 pi, that is 360 degree. So this angle, this is pi/4. So if we represent phase in terms of angle, so this will be pi/4. When we represent this in terms of time, the phase is T/8. So the phase of this particle P, this can be, we can say this is either pi/4 in terms of angle, in terms of time this is T/8. Now phase difference, what is phase difference? So difference in the phase of two vibrating particle is called phase difference. So कोई भी दो पार्टिकल जो while motion में, उन दो पार्टिकल्स की जो पोजीशंस में जो डिफरेंस है, we say that is phase difference. So for example, particle at y has a phase of pi/2 or T/4, and the particle at x has a phase of pi or T/2. Then the phase difference phi between them is pi minus pi/2, that is pi/2, or T/2 minus T/4, that is T/4. So the phase difference or phase, we can represent either this in terms of angle or in terms of time. Even we can represent this in terms of path difference. So difference of path can also be used to represent the phase difference. So there are different methods to represent the phase of particle. Now next, let's start with superposition of waves. What do we mean by superposition of waves? So principle of superposition, when two or more waves are simultaneously present at a single point in space. So अगर space में कहीं पे simultaneously दो या दो से ज़्यादा waves आ जाएं, then what happens? The displacement of the medium at that point is the sum of displacement due to individual wave. So here the displacement will be the sum of displacement due to individual waves. So this is what we mean by superposition, and this is principle of superposition, that say these two waves, they are coming. So at this point the two waves overlap, and the displacement here will be due to the sum of the displacement due to these two waves. So this is principle of superposition. Now next, superposition of wave can result in, now the waves, they can superimpose in different ways. There are different ways in which waves can superimpose. So mainly we are going to discuss three. Number one is interference of waves. Here the two waves, जो waves superimpose कर रही हैं, the two waves, they are of same frequency and they are moving in same direction. So when two waves of same frequency moving in same direction overlap, superimpose, the resultant phenomena is called interference of waves. When two waves of same frequency, they are moving in opposite direction, they overlap, they superimpose, the resultant phenomena, this is called standing wave or stationary wave formation. The third one is beat formation. So when two waves of slightly different frequency, moving in same direction overlaps or superimpose, the resultant phenomena is called beat formation. Now next, interference of waves, it can be of two types, constructive and destructive. So constructive कब होएगी? When the two interfering waves are in same phase. So we discussed in previous slide कि interference कब होगा? When two waves of same frequency moving in same direction overlap. Now if the two interfering wave, they are in same phase, then the resultant process or phenomena is constructive interference. And when the two interfering waves are in opposite phase, then this is destructive interference. So constructive interference occurs at a point when two waves have displacement in same direction. The amplitude of the combo wave is larger. In destructive interference occur at a point when two waves have displacement in opposite direction. Then the amplitude of the combo wave is smaller than the biggest wave. So superposition can involve both. Superposition में both can happen simultaneously. Constructive interference, destructive interference simultaneously हो सकते हैं at the same time, but at different positions. But positions will be different in the medium. So this slide, it shows the difference between constructive and destructive interference. So in constructive interference, what happens? These two waves, this red and blue, they are in same phase. They are in same phase means crust fall over crust, trough fall over trough. So red plus blue, this gives you green, this is the resultant wave. so its amplitude has increased. So if red and blue they have same amplitude, अगर दोनों का amplitude same A है, then the green has amplitude 2A. So this represents constructive interference. Now in destructive interference, the two waves are out of phase. They are in opposite phase, they are in same phase. Same phase, crust fall over crust, trough fall over trough. In opposite phase, crust के नीचे trough, trough के नीचे crust. So waves are out of phase by superposition. Red and blue completely cancel each other out, and if their amplitude are same, दोनों का amplitude same है, this green line it will represent the resultant, that means no wave. So this represents destructive interference and this represents constructive interference. So these are few terms which I think now by now you are familiar. Now in the next slide we are going to consider example of sound waves, how interference occur in sound waves. So for that, just see this represent wave. V stand for wave velocity, this is amplitude, crust, trough, this is wavelength L. Phase, this is position of crust or trough. Okay, we will be concerned only with relative phase or phase difference between two waves. So we are concerned only with phase difference. When we are talking about constructive and destructive interference, we say the waves are in same phase or they are in opposite phase. So we are talking about phase difference. So now let's consider this example. So this is interference of waves from two sources of sound. So two sound waves overlapping along a line. अगर दोनों source along same line है, they are overlapping, then what will happen? And if two sources are like this, spherical waves, then what will happen at this point? So the resultant phenomena, what is happening? This is called interference of sound waves. Now just see, two speakers are here. When the two waves, they are in same phase, so constructive interference will happen. So crust over crust and trough over trough. So this is example that two speaker sound waves में constructive interference हो रहा है. So the amplitude of the resultant wave increases. अगर दोनों waves का same amplitude था A, इसका A, दोनों का A है, then the resultant amplitude is plus 2A. So this is constructive interference. और constructive interference कब होगा? The condition is when the path difference, this is m lambda, when the path difference is m lambda, where m is 0, 1, 2, 3. So or this is integral multiple of this wavelength. If L stand for wavelength, L is length of a complete wave, then for every integral multiple of wavelength, the waves will be in same phase. So when the path difference, we say this delta D is path difference. When this is m lambda, where m, this is integral multiple of L, then the waves, they will superimpose and the resultant phenomena will be constructive interference. Now in destructive interference, we know it happens when the waves, they are in opposite phase. So for opposite phase, this L, the path difference, delta L, path difference, that is phase difference. We can measure phase difference in terms of angle, in terms of time, or in terms of path difference. So when it is L by 2, when the path difference is L by 2, then destructive interference occurs. So in this case, what happens? The output is 0. When both the waves, they are of same amplitude, the output will be 0. And the destructive interference occurs when this path difference is m plus half times of lambda. So m can be 0, 1, 2, 3. So this is integral multiple of L, and path difference is n plus half lambda. So these are the conditions when destructive interference occurs. So with this I conclude my lecture. Hope all of you enjoyed. Thank you.